Hi, welcome to session 3. This is our third session of 5. If you're literally just jumping on now, then there are 2 previous sessions and all the questions that we're doing across the 5 are linked in the description so that you can go and get literally everything that you need so that you can take part in this preparation for paper 3. All right, so let's crack on with it. We have a box plot question as our first one, and we're being asked to just plot the information from the table. So the minimum, the least height is 154. So we are going to pop that in place. We've then got our median for 165. Notice how I make that line just a little bit bigger. They're not too fussy about the lengths of the line, but always make that middle box a bit bigger is my advice. Our lower quarter is 161, so we pop that on. And then the next line is not our upper quartile. Our next line is the interquartile range, which is found by doing the upper quartile take the lower quartile. So a number I don't know, take away 161 is 7. So we're going to just add that 7 and the answer is 168. So we can put that line in. And then they're doing the exact same thing in that last bit. We don't have the maximum, we just have the range. The maximum, take the minimum is the range. So add the 20 on and it's 174. Now it's just a case of drawing your box and your whiskers to complete the diagram and you're done. Now, the next part of this question is asking us to compare the year 11s with the year 7s. And the way that we word this is the key. It is all about the box. Don't mention the minimum or maximum. There's no point at all. So compare the medians. So we can say that the year 11s is higher compared to that of the year 7s, and then compare the interquartile range. Now, notice how I've underlined the word height. Don't just say the interquartile range is greater, say particularly the height, and that will get you the mark. All right, our next question is a circle theorem. We've been given some information, so we want to pop that straight into the diagram. So 54 is EDA, and our ABC is 114. Now, whenever I can see a tangent in a chord in a circle theorem, I'm going to Z it out so that I can find that equivalent equal angle. So that is my alternate segment theorem. And label as you go so that you don't have to think about it at the end. They've given me the 114 for a reason. It is because of our cyclic quad. Now, cyclic opposite edges of cyclic quads add up to 180. So that would make that 66. And then the angle I'm actually looking for can be found by using angles in a triangle. So take away the angles you know, and you can see that our angle CAD is 60 degrees. Okay, so we have a shape that's being reflected in 2 lines, and then you're being asked to describe the single transformation. You need to physically do those reflections so that you can look at what you've got. So we're going to go to the x-axis, go to -1 and draw a line through it. And then we're going to reflect our triangle in that line, x equals -1. And then we're going to repeat the process with the y equals -2. So y-axis, go to -2, draw in your line, and then reflect your shape. Now, you could be using tracing paper for this. You could be counting away. It's whatever you're comfortable with, really. Now, the single transformation, T to S is a rotation. We can see it's been twisted. So we would write that it's a rotation. It's 180 degrees. And the center is actually where the 2 lines of reflection cross. So it's quite a nice one to find. There is an alternative way to describe this, and that would be to say it's an enlargement with a scale factor of -1 with the same center. However, that's quite unusual, and I've marked many papers, and I don't see that referenced very often at all. Okay, our next question is to make T the subject. So we're going to be rearranging. Now, T is in two places, and specifically, it's part of a denominator, which we need to get rid of as quickly as possible. So I'm going to bring that across to join the K as a multiplication. Because I want to make sure I multiply all of it, I've put it in brackets. Now I'm just going to expand the brackets. I want to get the t's on the same side. So I'm going to bring the two t's over to join the k t's. And I'm also going to get rid of anything I don't want at the same time. So the minus 3k can go across to the right-hand side. That's going to give me kt minus 2t equals 6 plus 3k. Now I'm going to factorize. I've got the t in two places. Obviously, I want a single t, but because they're in both terms, it means I can factor it out. And then the k minus 2 can move and land as a divide to finish off. So t equals 6 plus 3k over k minus 2. Okay, this is our big question. It's our circle geometry. Now, you don't have to draw a sketch. I'm going to draw one because I really like to get a feel for the question. I'm not trying to be super accurate, but I'm going to put on the details as clearly as I can. So I know that my circle has its center at 0, 0. I'm a little off, but I'm not worrying about that too much. A is the point 2, 6. So I can roughly decide where my coordinate 2, 6 is, and I can mark that on. And then I can see the line that is tangent, and I can pop that in as well. I want to stretch it through so it crosses the x-axis. If my x-axis wasn't long enough, I can extend it, and then I can pop that point on. P has an x coordinate that I don't know, but I do know the y coordinate. It's 0. I'm being asked to work out the area of the triangle OAP. So I'm just as well mark that on. And I'm also going to write down how to do the area of a triangle, base times height divided by 2. Now, if I look at my diagram, I can see that I actually do have the height. Point A is the tallest point of my triangle, so the height is going to be 6. So my problem really here is to get a value for the base. I know that the line for the triangle starts at 0, so I just need that x coordinate. I can work out the point on that line if I know the equation of the line. So that is ultimately my problem. I need the equation to the tangent. To start this off, I'm going to find the gradient of the radius because I've got 2 points with the radius. I've got the center 0, 0 and my 2, 6. So I can set up the gradient formula. It will be 6 take 0, 2 take 0, giving me 3. So my perpendicular gradient, which will be the gradient for my tangent, is minus a third. I'm going to use the equation formula y minus y1 equals mx minus x1. All I need to use this formula is a coordinate on the line and the gradient, and I've got both. So I'm going to replace my y1 and my x1 with the coordinate 2, 6, and obviously the gradient that I've just found will replace my m. We're going to expand, we're going to rearrange, we're going to get it in the form y equals mx plus c. When you do that, you will end up with the equation y equals minus a third x plus 20 over 3. I want to know the x value when y is 0. So I'm going to set my equation, minus a third x plus 20 over 3, to equal 0. I'm then going to just rearrange so that I can get x on its own and work out that x is actually going to equal 20. So I now have the base of my triangle. It's 20. So to finish off, I'm going to do 20 times 6 divided by 2. This gives me 60, which is the area of my triangle. So quite a big question there on the end, not necessarily for everybody. If you are wondering how I did the gradient, I used the rise over run formula that is y2 minus y1 over x2 minus x1. That detail wasn't shown, but that was what was happening in the background. All right, I'm hoping that you're finding the solutions helpful if you have got stuck along the way, and I look forward to seeing you in tomorrow's session.